This is part 2 of the video series with operations, radicals, and complex numbers, and we'll pick up with where we're multiplying the radicals, and the square root of 3 times the square root of 3 is the same as 3 to the 1/2 power times 3 to the 1/2 power. And so this allows you to bring in the product rule if you wanted to look at it from the view of rational exponents. So if we were to multiply these with the same bases, you're allowed to add the exponents. So this would actually be 3 to the first power, because 1/2 plus 1/2 is 3, so we would get 3. If we take square root of 3 times the square root of 3, we would actually get the square root of 9, and the square root of 9, the principal square root, would be the square root of 3. So when multiplying these, we're actually can just multiply the radicands and get 3 as an answer. Let's look at the next problem where you're multiplying. You get you would actually multiply the 2 and the 3 factors, so that would give you 6. And then the square root of 6 times the square root of 8 would give you the square root of 48. And then we always want to try to simplify that, so you're thinking perfect square lists. That would be 16 and 3. And that would simplify to 6 times 4 times 3, which would simplify to 24 square roots of 3. So remember, you're multiplying the radicands, and you would multiply the factors. And then here is a distributive property. So the square root of 25, or excuse me, square root of 5 times the square root of 5 would be the square root of 25, plus the square root of 5 times 3. Well, we would write the 3 to the left times the radical. And then we know the square root of 25 would be 5 plus 3 square roots of 5. I can't do anything more because these two terms are not like terms. So you would be finished. Next one is using a distributive property. So multiplying the radical times 2 terms here. So this would be 3 times the square root of 60 plus 3 times the square root of 6 times the square root of 18 would be 3 times the square root of 108. And 108 would be square root of 36, and the square root of 3 times 3 plus, and then the square root of 60. Square root of 60 would be the square root of 4 and the square root of 15. So this one's a perfect square, so it gets you 3 times 2 times the square root of 15 plus 3 times the square root of 36 is 6 times the square root of 3. So this would be 6 square roots of 15 plus 18 square roots of 3, and simplified because the radicands are different. They're not the same. With this problem, I'm going to multiply the square root of 5 to both terms, and I'm going to get -4. Square roots of 5, square root of 5 times the square root of 8 would be the square root of 40 plus 2 square roots of 50. And so -4, and this will be the square root of 4 and the square root of 10 plus 2, and 50 would be square root of 25 and the square root of 2. So here's a perfect square, and here's a perfect square. So this would be -4 times 2 times the square root of 10 plus 2 square, and the square root of 25 is 5 square roots of 2. And so this would become -8 square roots of 10 plus 10 square roots of 2. And you can't simplify anymore because the square root of 10 cannot factor into another perfect square in a factor, and the square and 2 is prime, so the square root of 2 would not be able to simplify. And then finally, what we have here is we're going to use the distributive property twice, which will provide us with 4 terms. So the square root of 8 times the square root of 3 is the square root of 24. And then this will be -3 square roots of 160. And this will be 2 times the square root of 30. And then this would be 6 square roots of 200. Now we just look at each of the denominators and we try to simplify those. So the square root of 24 would be the square root of 4 and the square root of 6. So that would be 2 square roots of 6 minus, and then 160. $160 would be the square root of 16 and the square root of 10. So this would be 3 times 4 times the square root of 10 plus, and the square root of 30 does not have a common factor that's a perfect square. The factors are 1, 30, 15, 2, 6, and 5, so we'll leave it as 2 square roots of 30. And then 200 would be 100, square root of 100, square root of 2, square root of 100 is 10. So what we have here is 2 square roots of 6 minus 12 square roots of 10 plus 2 square roots of 30 minus 60 square roots of 2. Not a single one of the radicands are the same, so that would be your simplified form. So we've talked earlier that we knew that I would have to equal square root of -1. So now we're asking, well, what would I squared be? Well, if you squared both sides, you would get I squared on the left, but this one, square root of -1, when you square that side and square both sides, there's your power rule, so you actually get I squared is equal to 1/2 times 2 actually gives you just -1. So if I is the square root of -1, then I squared is equal to -1. So we're going to use that idea to simplify. So 8 plus 7i squared just means that we're going to multiply this out. So this would be 64 and 56i and 56i and 49i squared. So there's not another constant that I can add together with anything else, so that'll be 64, and then 56 and 56 would be 112i plus 49. Now what do we know I squared to equal? -1. So we end up multiplying by -1. So this will be 64 minus 49 . So 64, take away 49, plus 112i. So that will be 15 plus 112i. And that would be your simplified form of 8 plus 7i quantity square. So we're multiplying just as normal, in the past we've seen x's in our problem, but now we've got the imaginary number I. And then when we multiply the last two terms, we saw we were getting I squared. So we know that I squared is going to equal that I squared would equal -1. So here, let's take 3 plus 8i and -1 minus 2i. So these are different. So we get -3, -6i, -8i, and a positive 16i squared. So -3, these are like terms, so that's -14i, and then 16 and I squared is -1. So this will be -3 minus 16 minus 14i. So that'll be -19 minus 14i. And notice that the result is written in the form a plus bi for your complex number. Third, we'll multiply this out. We're going to get 42 and -28i and -12i and a positive 8i squared. So we know that 8i squared that I squared is going to be -1. So then that's going to change this to be a -8. So you get 42 minus 8. And then 28 and 12 should be -40i. And so 42 take away 8, and get 34 minus 40i for part C. Part D is very similar to part A. So a multiplying strategy that you could use in your mind to multiply these out is you could square the 2, which gives you 4. You could multiply 2 times -3 and get -6, and then double -6 to get -12i, and then you could square the last term, which would give you 3i squared. And so this would be -3, so 4 minus 3 minus 12i would give you 1 minus 12i. And so that's kind of a shortcut and a fast, the fast version of multiplying there. But if you go ahead and multiply these out, you're going to get 4. You get -6i, -6i, and a positive 9i squared. And that should actually be 9 over here because you're squaring the 3, which would be -9, which would be -5. So that should be -5 minus 12i. Here, I know I'm going to get -4 minus 12i minus 9. And then, so these two would be the same, so that'd give me -5 minus 12i. There's your result. So what is it that we have to remember when you're multiplying with complex numbers is just know that there's going to be an I times an I at some point, and that I squared is -1. With rationalizing, there's a lot of different methods in order to rationalize. One method is, well, we don't want the denominator to have a radical, so what we do is we call it rationalizing it. We would just multiply by what's in the denominator in regard to the radical. So square root of 10 is in the denominator. I would just multiply numerator and denominator by square root of 10, and I'm going to get the square root of 20 divided by 10. Because what happens when you square square root of 10, you get 10. So then square root of 20 would be the square root of 4 and the square root of 5, all divided by 10. And the square root of 4 is 2 times the square root of 5 divided by 10. So what's your final? Well, 2/5 will simplify to give you 1 square root of 5 divided by 5. Now that's one way to simplify that. Another way is to take the square root of 2 divided by, and then take the square root of 10 and factor them, and then these two would divide out. So that would leave you with 1 divided by the square root of 10, which I still need to rationalize. So this would be the square root of 10 divided by 10. And I'm sorry, that should be 5. Jumping ahead of myself there. That should be 5, which would make these 5. And this one 5. So I'm just going to erase all of those. So this would give me 1 divided by the square root of 5. And then when I rationalize that, I get the square root of 5 divided by the square root of 5 times the square root of 5 is the square root of 25, or 5. So either way, how you want to look at that to simplify, there's not a wrong answer or a wrong path in between those two. Second one, I've got the square root of 15 and the square root of 12. So the square root of 15 would be the square root of 5 and the square root of 3. And the square root of 12 would be the square root of 4 and the square root of 3. So this is one way, is to just try to simplify into factors. And then what would happen here is that those would divide out. And what's the square root of 4? The square root of 4 is 2. So you're actually left with the square root of 5 divided by 2. Okay, I didn't have to rationalize in that case, but if I rationalize here, and what I would get is square root of 15 times the square root of 12 would be the square root of 180 divided by 12. Well, 180 has a perfect square factor of 36. So the square root of 36 times the square root of 5, all divided by 12, which would be 6 square roots of 5 divided by 12. And then if I keep come over here, and I'm going to get 6 square roots of 5 divided by 12. Well, what happens to 6/12? It simplifies to 1/2. So I get square root of 5 divided by the square root of 2, which is what I found up here when I simplified and broke square root of 15 down into 2 factors, square root of 12 down into 2 factors. You get the same thing. This one is just your textbook rationalize the denominators. So one method, again, square root of 4 is going to be 2. And 2 times the square root of 2, well, the 2's will actually divide out, and you're left with 1 times the square root of 20, which I'm going to have to rationalize. So the square root of 20 divided by 20 is 20. So square root of 20 divided by 20, and then I know the square root of 20 will simplify to be the square root of 4, square root of 5 divided by 20. So that'll be 2 square roots of 5 divided by 20, or 1 square roots of 5 divided by 10, because 2 will divide 20 10 times. Or we could write it as just the square root of 5 divided by 10. So square root of 4 we said was 2 divided by 2 is, now what we did on the top example here is we actually rationalized it. So if I come back here and look at what if I don't rationalize it and I just leave it as the square root of 4, well, 20 is actually 2 times the square root of 4 times the square root of 5. And then the square root of 4's divide out, and you're left with 1 divided by 2 square roots of 5, which I cannot have square root of 5 in the denominator, so I'm going to need to rationalize it. So I get square root of 5 divided by square root of 5 times square root of 5 is 5. 5 times 2 is I get 10. Same answer as above. And then finally here, let's, I can't really simplify the square root of 5 anymore, or the square root of 2. So this is going to be just truly a rationalized problem. I don't have to bring the 3. I can just take the radicand. So that'll be 4 square roots of 10 divided by 3 square roots of 25. And the square root of 25 is 5. So 3 times 5, 4 square roots of 10. So final answer would be 4 square roots of 10 divided by 15. Conjugates. We talked about conjugates in our first unit, and that's when you have the same terms, just have a positive or negative. Well, we can have the same thing using imaginary numbers. So we know I squared is -1. So 1 plus 9i divided by -2 plus 9i. I don't want I in the denominator, so what we're going to do is rationalize this. We're going to multiply by its conjugate. So notice that all the signs are the same. -2, -2, 9, 9. One's positive, one's negative. So the terms are the same, but the signs are different. So this will give me -2 in the numerator. This will give me -9i. This will give me -18i. And this will give me -81i squared. That's the numerator. And let's use a line here to kind of separate that numerator denominator. So here, when I multiply, notice I'm multiplying conjugates. So this will be 4. And it will be a positive 18i. And this one will be a -18i. And -81i squared. So these divide out. And up here, you're left with -2 minus 27i. And then what's this I squared? That's -1, so it'll be plus 81. So -2 plus 81, you should have 79. 79 minus 27i. And notice when you took the conjugate and you multiplied by the conjugate, you actually lose the middle term. And then this -81 I squared would be positive 81. So that would be, this will be your numerator, but your denominator would be 4 plus 81, or 85. So we have 79 minus 27i divided by 85. Second, let's take the -7 plus 6i divided by 10 plus 5i. Okay, I don't need I to be in the denominator, so I'm going to multiply by the conjugate, which will be 10 minus 5i and 10 minus 5i. So I'm going to distribute, so that'll be -70. That'll be a positive 35i. That'll be a 35i, and then that'll be 60i, and then -30i squared. So I get -70, and plus 95i minus 30i squared. Well, I squared we know is -1, so that'd be 30 times -1. So I'm going to have -70 plus 30 plus 95i. So this will be -40 plus 95i. And that's what you're doing when you're dividing complex numbers, is that we don't want I to be in the denominator, just like we don't want a radical to be in the denominator. So we multiply numerator and denominator by the conjugate of what you see in the denominator. So recap, -2 plus 9i, that's where we multiplied by the reciprocal, which was -2 plus 9i. And then the denominator here was 10 plus 5i, so we multiplied by the reciprocal, or the conjugate, excuse me. 10 plus 5i in the denominator, 10 minus 5i in the denominator. Those are conjugates, but this makes the ratio 1. So 1 multiplied by anything doesn't change the problem. So last two, take -2 minus 10i divided by 9 minus i. So the conjugate would be 9 plus i and 9 plus i. So we're going to start here and distribute. We're going to get -18, -2i minus 90i and minus 10i squared. So then the conjugates is 9 minus I and 9 plus I. So what you could do is understand that you're going to square the first term, which is 81, and you're going to take the difference of what you get here, and that would be -I squared. Because the two middle terms are going to divide out, so that's going to give you 81. And this will give you a positive 9i and a negative 9i and a negative 9i squared. So those go to 0, and you're left with 81 minus 9i. Write that again. That's going to be 81 minus I squared. And I squared is 1, so we would have 81 plus I. So what we would have in the denominator with that conjugate is the 81 minus I squared, and I squared we said was -1, and so we're subtracting a -1, so notice that the signs would become +1. So clean up the numerator and we'd have -18, and then this -10I squared would be +10, and then this -2I and a -90I would be -92I, all divided by 82. And so then I'm going to have -8 minus 92I divided by 82. And then you want to try to simplify this as much as you can, because this is really -8 divided by 82 plus a -92I divided by 82. So you try to simplify it as much as you can, and you would just look for common factors. So you just continue to simplify that. And so the -8 and the 82 both divisible by 2. So -4 41st plus -46I divided by 41. Or you could just use 41 as one denominator and have -4 minus 46I. And that would be your result. And then last one is we'd say -7 plus 6i divided by 10 plus 5i. So the conjugate would be 10 minus 5i. 10 minus 5i. So then we would just multiply. So this would be -70. And this would be a positive 35i. And this would be positive 60i. And this would be negative 30i squared. And then remember what happens with the denominator. When you take the conjugate and you multiply that, you're going to get 10 times 10, so you're going to get 100. And then that would be negative 50i, positive 50i, so that would disappear, and then you're going to get negative 25i squared. So you would get 100 plus 25 in the denominator, and then negative 70, and then this negative 30i squared would be negative times a negative, so that would be a positive 30, so negative 70 plus 30, and then the 35 and 60 would be 95i. And so this would be negative 40 plus 95i, all divided by 125. And so then we would just separate it. Negative 40 divided by 125 plus 95i divided by 125, and they're all divisible by 5. So you continue to simplify, and so divide everything by 5, and you're going to get negative 8/25 plus 19i 25th. So you could write that as just one denominator. So negative 8 plus 19i all divided by 25. So just to recap, when you're multiplying, when you're dividing, rationalizing the denominators, you want to multiply by the conjugate. So you're always looking at the denominator, 9 minus I, so you would multiply by 9 plus I. You look at the denominator here and you see it's 10 plus 5i, you would multiply by 10 minus 5i in the numerator and in the denominator.